Morning guys, today we're going to be doing Chapter 7, Lesson 3.4, How Can I Find the Unknown? So we're going to start with the introduction this morning. Today you will use variables to represent specific unknown quantities. Then you will use equations to represent real-life situations that involve unknown quantities. You will also explore how equations and inequalities can be solved to determine the values of the unknown variables. So our first core problem for today, question 112, finding unknown variables with equations. So reading the question, letter A says an airplane is at full capacity carrying an unknown number of passengers and 7 crew members. What variable could you use to represent the unknown number of passengers? So we've been talking in class about when we don't know something, we use something called a variable. A variable could be any letter that represents a value of something. So we've been using typically X in the past couple lessons, but we can start to use different letters to represent the situation. For example, maybe we can use P to represent the number of passengers. This is called defining the variable because we're telling somebody who's looking at our work what the variable is representing. So then it says to write an expression for the total number of people on the plane. An expression does not have an equal sign. For example, X minus 3 is an expression. So an expression is a numerical sentence, again, that does not have an answer, therefore no equal sign. So if we think about the total number of passengers, it really has to equal the number of passengers plus the crew members. Okay? And we already said from beginning of letter A that we're going to use P to represent passengers. And the question tells us that there are 7 crew members. So an expression that represents the number of people on this plane would be P plus 7, the number of passengers plus our 7 crew members. Moving on to letter B, it says equations can be used to help you find the value of an unknown variable. Equations have expressions on both sides of an equal sign. For example, 9 times the group, 2x plus 7, is equal to 288. So an equation is 2 expressions with an equal sign in the middle. Lucky for us, we already have one expression that we just created. So on one side of our equal sign is going to be P plus 7, the passengers plus the crew members. We also know that the plane was designed to hold 241 people. So the number of passengers plus our crew members is going to be equal to 241. So now we write an equation that tells us about the total number of people that can fit on our plane. Question C, it says, thinking about the idea of inverse operations, determine the value that your variable needs to be in order to solve your equation. That is, how many passengers can fly in the plane. So where we left off, we had that the number of passengers plus 7 crew members was equal to 241. So remember that the inverse was undoing something, or a lot of us said that it was like the opposite. So if we want to get rid of this 7 over here, the inverse or undoing would be subtracting 7. And remember, anything that we do to one side of something, we do to the other. Just like in a fraction, if we multiply the numerator by a number, we also need to multiply the denominator by that number. So how we write that is the inverse of 7 is subtracting 7. So we also need to subtract 7 from the other side. That leaves us with the number of passengers is equal to 241 minus 7, which is 234. So therefore, there could be 234 passengers on the airplane. Letter D. Whenever it flies, the airplane is not always at full capacity. Using what you wrote in part B, write an inequality to relate the total number of people to the capacity of the plane. So if we look at this word inequality, okay, we already know what equal means, that the two things are the same or equivalent to one another. And inequality means something that is not necessarily equal to something. So in an inequality, use the mathematical symbol for less than or equal to. So as a quick review, our inequality symbols are less than, greater than less than or equal to and lastly we have greater than or equal to. So if we want to write an inequality in letter D for this situation, we know that the passengers plus 7 people has to be less than or equal to 241 people. Because we can have exactly 241 people, but we can also have an airplane that has less than that on it, meaning maybe we didn't sell all the seats on the airplane that day. Lastly, letter E says, what values for P will make the inequality you wrote in part D true? That is, what are the solutions to the inequality? So we already talked about P is, if we solved it earlier, has to be less than or equal to 234. So the maximum number of passengers that we can have on the airplane is 234. Okay? But we can also have less than 234. All right, let's keep going. Our next core problem for today is question 113. According to the attendance office, Lakeside Middle School has 57 fewer students than Xavier Middle School. You want to determine the number of students that attend Xavier Middle School. When you use a variable to represent an unknown, you will need to define your variable, using a let statement to communicate what your variable represents. For example, in problem 7-112, you could have said let P represent the number of passengers. And we actually already talked about that in question 112. We always want to allow the person, anybody who's looking at our work, to know what it is that we're trying to represent. So write an algebraic expression. Remember, algebraic involves a variable for the number of students at Lakeside Middle School. Make sure that you define the variable you choose. So Lakeside Middle School has 57 fewer students than Xavier Middle School. Okay, so what do we know here? So we know that Lakeside has 57 fewer students, which means we're taking the number of students from Xavier and taking 57 students away from that. So here my variable would represent the number of students at Xavier Middle School. Okay, so if we take this variable and take 57 away from it, that should give us the number of students who are attending Lakeside Middle School. Letter B continues to say the attendance office says that there are 403 students at Lakeside Middle School. Use the expression that you wrote in part A and write an equation for the number of students at Lakeside Middle School. So in letter A here, we wrote that the number of students attending Lakeside Middle School was x minus 57. In letter B, we can go ahead and use that same expression and set it equal to another expression and therefore having an equation. So in letter B, they give us the information that there are 403 students at Lakeside Middle School. So this equation now represents the number of students who attend Lakeside Middle School. Letter C, how many students are at Xavier Middle School? Explain how you use inverses to find your answer. Write your answer in a complete sentence. So for question B, we're going to use our equation that we wrote here, okay, because we know that this represents 403 and both of these equal or represent the number of students at Lakeside Middle School. So earlier we talked about if we want to get rid of this 57, the inverse of subtracting 57 is to add 57. But I can't add 57 over here unless I also add 57 over here. What that does is it makes sure that our values are still equal and that we didn't change the original value of our problem. So if I take away 57 from x and then add 57 back, think about a number line going 57 spaces to the left and then 57 back. What we really have is just our x. Okay, and over here, 403 plus 57 gives us 460. So the answer to our question, our variable here, would be 460. Okay, and that represents the number of students at Xavier Middle School. And this is where defining our variable in the very beginning becomes very helpful, because now we know what we solved and what that actually represented. So our last question, letter D, says use your equation to show how you know that 550 is not the number of students who are at Xavier Middle School. Test two other values that do not make the equation true. How many solutions are there to the equation that you wrote in part B? So if we have this equation, x x minus 57 is equal to 403, okay? We already know what x can equal. We just solved that. So we can do a lot of guessing and checking. For example, they're really asking us, does 550, if we replace it with our variable, give us 403? The answer would be no. 550 minus 57 is 493. And that does not equal 403. Therefore, 550 cannot be a correct answer. We can go ahead and try another answer. Let's say that we guess that there were 457 students at the school. We want to know, does this number that we guessed minus 57 give us 403? We know we're a lot closer, but 400 does not equal 403. Therefore, again, this is an incorrect answer for the value for x. Go ahead and try one more value and see if you guys can get it equal to 403. What you should find out, how many solutions are there to the equation that you wrote in part B? There's only one. There's only one, and we already found out. So core question 114 says Ellie is building a dollhouse. She has boards that are two different lengths. A long board is 17 inches than the short board. Letter A, draw a picture showing how the short and long boards are related. The length long board is 50 inches. The length of the short board is unknown. So drawing a picture is always a great way to show something, especially when they give us measurements. So we know we have one board that is short, and we know that we have one that is longer. Okay, so what else can we identify our drawing? We know that the long board is 50 inches. We know that the length of our short board is unknown, so we use a variable to represent that. But we do know that the length of the short board is 17 inches smaller than that of the long board. Okay, meaning that this extra distance here is 17 inches. So many of you guys can probably say, well, if this is 50 and this is 17, you guys probably make a good idea as to how long shortboard actually is. So that kind of leads us then into letter B. Letter B says to write an equation that shows the length of the long board and how it's related to the length of the short board, defining your variable first. So letter B, we know the variable we used, x, was equal to the length of the short board. It's what it represents, it's what it means. If we look at our visual here, we know that the short board plus the additional 17 inches is the entire of the long board. So we know x plus 17 has to give us 50. Letter C. Ellie estimates that the length of the short board is between 30 and 40 inches. Test at least 3 values in this range in your equation. Were any of the values you tested a solution, and how do you know? So, having this equation that we wrote in letter B, we're going to go ahead and pretty much, it's called plug and chug. Okay, we can use guess and check, and we're going to choose different values of x to see does in fact with something that's equal to 50. So, starting with our equation, x plus 17 is equal to 50. you should go ahead and choose 3 different quantities for x to see if it does give you an answer of 50. Let's do the first one together. If we said that x is equal to 20, is 20 plus 17 equal to 50? You guys probably can, in your head, can say that no, this is equal to 37, and 37 does not equal 50. So you should go ahead and try 2 more of your choice and see, can you guys plug in a number for x to give you an answer that is equal to 50? Letter D. What is the length of the shortboard, and is there more than one possible answer? So in letter C, we were using the equation that we wrote in letter B. X plus 17 is equal to 50. And we are trying to find out a value that we can plug into x to make this statement true. We know from earlier talking about if we want to get rid of the 17 here, meaning we want to undo that 17 and get rid of it, we have to use something called the inverse. The inverse of adding 17 is to subtract 17. And if we want to keep the integrity of this problem intact, we need to subtract 17 from both sides. So x plus 17 minus 17 leaves us just with our variable, and 50 minus 17 gives us 33. So the answer to our variable is that x is equal to 33 inches. And what did we say x was equal to? The length of our short board. So the answer to our question is that our short board is actually 33 inches, and our long board, which was given, was 50 inches. Is there more than one possible answer? No. Only one number can be plugged in here to make this a true statement. And we found out using inverse operations that that answer is 33 inches. Question 115. Jeffrey is comparing the number of pages to his science book to his math book. Letter A. Jeffrey does not have science class today, so he left his book at home. The number of pages in his hardback science textbook is unknown. Jeffrey also has a paperback science lab manual. Each lab activity is 2 pages long, and there are 25 different lab activities. Define a variable and write an expression for the total number of pages of science materials, including the hardback textbook. So first of all, it tells us here in the question that the number of pages in our hardback science book is unknown. So when we're writing a variable, for example, let's use S for science, that's going to be the number of pages in the hardback science book. So the second part asks us to go ahead and write an expression to represent the total number of science materials that he has. We know that 2 things make up his science materials. His hardback book, which we already identified as being S, but we also have his lab manual. So his lab manual says each lab activity is 2 pages long, and there are 25 different lab activities. So think to yourself, how many pages would that be? 2 pages long for each activity, and there are 25 activities. Well, 25 times 2 is equal to 50. So the expression S plus 50 tells us the total number of pages in his science materials. The number of pages in his hardback book, the number of pages in his lab manual. Question B. By looking at his math book, Jeffrey thinks the total number of pages of science materials is more than 425 pages of his math book. Write an inequality. Remember, inequality means not necessarily equal to relate the number of science pages to the number of math pages. In the inequality, use the mathematical symbol for greater than. So, we already know that the number of science materials he has is S plus 50. What we want to know, is that greater than the number of pages in his math book, 425. So this inequality means the number of pages of his science materials is greater than that of his math pages.